All right, welcome back. Here we are. Let's continue something we started, or we were trying to finish up on Friday, and we'll start here Monday morning. Do a few more, clear up a few more of the issues that we had. I know y'all struggle with some of y'all struggle with this, um, but doing one more formula problem. Chapter 1-3. This is actually problem number 63 in the book. It looks pretty bad. They've asked us to solve each of those, every one of them. We're going to solve, and we're going to solve it for x, okay? I'm going to solve it for x. So here it goes. All right, there's two issues with this problem that I noticed right up front. We've got fractions, but you get lucky because both of those numbers are the same. So first thing I'm going to do, and let me get rid of those circles so there won't be too many more things on here. All right, the first thing I'm going to do is I'm going to multiply each and every part of this by the number 5. Okay, now I'm going to actually write this out for you. I'm going to multiply 5 times this guy minus 5 times, let me back up, minus 5 times this guy is equal to 5 times this guy. And I'm going to plug them all back in now. This dude's 3ax over 5. This guy's 4c. This guy's ax over 5. Keep in mind now we're trying to isolate the variable x. The problem is there's two of them. So I got to get them on the same side. But before I can do any of that, I got to get rid of the fractions. We've already done that. 5's canceled. Leaves me with a 3ax. This time, nothing cancels. You got to actually multiply it out if nothing cancels. That's 20c. Once again, this side cancels. Leaves me with just ax. A question my kids usually ask: what happens if they don't cancel? What happens if it's not the same number? You have to find an LCM. That's an acronym you learned in Algebra 1, and you guys can look that up in your book. Okay? All right. All right. This problem now looks just like a problem we worked in class Friday, where we had to isolate things, the same variable. We got to get it on the same side. Okay? So the first thing I'm going to do, I'm going to move the ax over here, and I'm going to move the 20c over here. Okay, so just to save a little time on the video, I'm going to actually just do that. So I'm moving the ax over here and make it negative. Y'all should know how to, if I was showing that work, minus ax, minus ax. And I'm going to move the negative 20c over here and make it positive. Okay? Now we've got the variable that we're needing to solve for, x, isolated on the left side now. Okay? And now we can just come back in here and go, all right, we got a GCF. It's x. Factor it out. It's going to leave me with a 3a minus a over, I'm sorry, not over, close parentheses, is equal to 20c. All right, we're looking good now. What happened is, though, this time I got, I always told you guys, or I've told you guys since last Monday, I always look and see if there's any way you can simplify these things as you go, like terms right there. So, first thing I'm going to do before I start doing any kind of division is I'm going to make that subtraction. 3a minus 1a is 2a. All right, now this thing's looking better and better with every step. Okay? All right, now I've got my x by itself. It's multiplying. Remember, I told you guys in class, look and see what x is doing. It's multiplying. So I'm going to divide both sides by 2a. 2a. All right, cancels. X equals, you've got to reduce 20 over 2 is 10. That 10 will be on top. If you want to do it like this, that'd be 1, that would be 2. And then you'd have c, so that's 10c over a. That's all your answer is. Not a real good way to check these, but just go back and run through your numbers. I'm going to do a few more of these at the beginning of class. May do a one problem quiz with you guys at the beginning of the class. So please look at the problems on page 23, numbers 55 through 64. We'll talk a little more about that on Monday. All right, guys, a new chapter. This one's short and sweet. Chapter 1-4, Solving Inequalities. A couple of notes. And I'll say this once. I'll say it several times. These things, first of all, they solve just like equations. Okay? They solve just like equations. The only difference is instead of a equal sign, you've got an inequality symbol. The only thing that is different from here on out is the graph of this deal. And it ought to make sense to you. If I say x equals 5, then x equals 5. But if I say x is greater than 5, then that's a much bigger solution set. So you got to be careful. I'm going to go a little quicker here, so y'all keep up. Here we go. This thing solves just like a two-step equation where we would just simply add 12 to both sides. And add 12 to both sides. All right, cancels. 3x less than, not equals, less than 15 divided by 3 now. See how it actually solves just like an equation. X is less than 5. Now there's your solution, but we can't just have a solution with an inequality. The solution set is much bigger with an inequality. It's a little different. So we actually have to come in here and graph this thing. All right, so let's graph it on a number line. Be a little lazy here. There's 0. Somewhere out here is 5. Less than and greater than is an open dot. What that means is x is less than 5. That means that this graph starts at 5 but does not include 5. For example, if I plug 5 in for x, 5 is not less than 5. So the open dot helps us to remember that. And the arrow always goes in the direction of the inequality symbol. Okay? If it would have been less than or equal to, the dot would have been solid, and the direction of the arrow would have been in the same direction because it's still less than. But the fact that it's equal to would have meant solid dot. If that would have been an equal to there, 5 is not less than 5, but 5 is equal to 5. So that's the difference in the dots, okay? So be careful with that. Okay. One other type problem in here is a compound inequality, okay? It's the same scenario, but it's more than one. And I'm going to do a couple of more of these in class on Monday, but these are what we call and that's the example I'm going to work as an and problem. Monday we'll come back in here and I'll show you how to do the or problems, okay? That's an ugly R, sorry. All right, so you got and or. All right, a compound inequality is basically an inequality we will solve two parts simultaneously, and we'll put them on the same graph. All right? Compound inequality. I believe this was actually example 4 in your book. Okay? And here we go. Everything else is the same, guys. We're going to add 1 to both sides, and we're going to solve the inequality on the left first. You get 3x greater than negative 27 divided by 3. Divide by 3, and x is greater than negative 9. There's one of my solutions to my compound inequality with and. All right, let's get over here on the right side now. Subtract 7. Subtract 7. Gone. 2x is less than 12. I'm going to divide by 2. And x is less than 6. And there's that. Let me get me a little quasi number line, put her down here. All right. What color do y'all want? Blue sounds good. There's 0. Somewhere over here is 6. Somewhere out this way is -9. Appreciate you allowing me to be lazy. I'll graph the 6 in green. 6 is going open dot to the left. -9, we'll graph it in red. It's greater than, open dot to the right. The solution set for this problem lies between here. I'm sorry, I wouldn't go far enough. Okay, the solution set. But remember, open dot, it goes up to 6 but does not include 6 because 6 is not less than 6. Same thing with -9. -9 is not less than -9. So my solutions are all between -9 and 6. To check your answer on this one, just pick one in between there. Let's pick, I don't know, 1. Number 1. Plug it in both of them. Is 1 greater than -9? Check. Is 1 less than 6? Check. Okay? That's what it means to be a solution for an inequality or a compound inequality. Remember, we're going to go over OR on Monday, and I have a couple of examples for you guys to work real quick. Now, there's a couple of things I didn't go over in here, so you may have to recall a few things from Algebra 1, so be careful with these, okay? All right, I'll be back with these worked. All right, there we go. Let's walk through both of them real quick. Okay, here we go. Sorry about that announcement. Two-step inequalities here. Okay, had to distribute to 3x minus 15, 3 times x, 3 times 5. So I get -2x less than 3x minus 15. I move my 3x over because we got to still solve for x. So you got minus 3x, that's -5x. Divide both sides by -5. And x is going to be greater than 3. When you multiply or divide by a negative number, you flip the inequality. That's a rule y'all went over in Algebra 1. Just wanted to see if y'all remembered it. The graph part's easy. Open dot at 3, graphs to the right. Then I had an AND problem for y'all, where you had to solve both of them. So here we go. I subtracted 3x, gives me -x. Then I added 1. You get -x is less than or equal to 1. All right, but I hope what you remembered is that actually it's not just a -x, it's a -1x. So you divide both sides by -1. And when you multiply or divide by a negative number, you flip the inequality symbol. So instead of less than, it's greater than. Same thing over here. Move your 4x over, that's -4x. -4x, that's -3x. Greater than -9. Divide by -3. X is less than now 3. And once again, you go graph them. At -1, greater than or equal to, solid dot to the right in red. And then at 3, open dot to the left. And then I highlighted your solution set. I'm going to talk a little bit more about that Monday. Here are the problems I need you to look at for Monday. And these things will actually not be due in the notes, and everything from this lesson will be due Tuesday. Okay? Our startup Monday will involve, our startup Monday will be equations and probably 1 or 2 formulas. Okay? I hope you guys have a great weekend, and we'll get after it Monday. Let's have a good week, okay? Good week, because we got some stuff coming up that's going to be a little bit more difficult than what we've done, so we're going to have to buckle down and do our best, okay? Good job. I'll talk to you Monday.